Hello everyone. In this video, we are going to cover section 5E, correlation and causality. Correlation here means linear correlation. Let's firstly read the definition for correlation. A correlation exists between two variables, let's say variable x and y. When higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. Again, here, correlation we mean linear correlation. We use a scatter plot to describe or analyze the correlation of two variables. A scatter plot is a graph in which each point represents the values of two variables. For example, if we have a scatter plot here, in a rectangular coordinate system, let's say x-axis would have the values for variable x, and y-axis would have the values for variable y. And turns out the scatter plot look like that. You can see higher values of x correspond to higher values of y, right? And if you look at the scatter plot, you see a linear pattern. You see a linear pattern, and the linear pattern is go up as x assume higher value and y assume higher value as well. So when that happens, we say there is a linear correlation between the two variables, and that correlation is positive. What if we have a scatter plot? In the two-dimensional space, we use x-axis to take the values for variable x. We use y-axis to take the values for variable y. What if the scatter plot turns out just have a lot of values, a lot of points? All those points are subjects in your sample. For each subject corresponds to each individual point. It has a value for x, it has a value for y. I think we talked about scatter plot before the spring break. Remember the waist circumference and the arm circumference? Remember that example? Yeah, that is a scatter plot. So let's say we have a scatter plot like this. Would you also see the pattern, the linear pattern? Yeah, this is also has a linear pattern. This one is stronger, but this one is a weaker, but it still has a linear pattern. But this linear pattern is going down. When that happens, we say there is a negative correlation between the two variables. Okay? For example, if we let x be the price of a product, y would be the demand. How many people they are willing to buy the product. Yeah, so if you raise the price, then the demand would go down. I'm not talking about luxury, okay? The normal, regular products. If you raise the price, then less people would be able to afford it. So the demand would drop. So you will see a negative correlation between the two variables. And for the positive one, as I mentioned before, we had an example. X is the waist circumference, and Y is the arm circumference. It makes sense that we have a positive correlation here, because if a person has a very big with the circumference, then probably he has also a bigger arm, vice versa, right? So this is a positive correlation, this is a negative correlation. They are both scatter plot. Scatter plot is a two-dimensional space. It describes the relationship of two variables. So in our textbook, we classify the correlation here into three categories: no correlation, positive correlation, negative correlation. We have talked about positive and negative correlation. And what is a no correlation? If you look at a scatter plot, and there is no apparent, obvious relationship between the two variables. I think we also saw something in a class before, like the scatter plot is kind of like the scatter plot, the points are like all over, right? Remember that? Yeah, x variable represents the weight of the subject, and the y variable represents the pulse rate, heartbeat of the subject. Turns out you don't see the pattern, you don't see a linear pattern, so then we can conclude there's no correlation between the two variables. Okay, again, we are talking about linear correlation. If you have a pattern, something like that, well, we can say y somehow depends on x. There's a pattern there, but it's not a linear pattern. Okay, it's not a linear pattern. We are talking about linear correlation. Let's read the definition for no correlation, positive correlation, and a negative correlation. No correlation. There's no apparent relationship between the two variables. Positive correlation. Both variables tend to increase or decrease together, like this one. Negative correlation. One variable increases while the other decreases, like this one, right? Well, now the whole section here is talking about correlation. We're gonna go deeper. Not only just to know what is a scatter plot, what is a positive or negative correlation, we also have to know how do we measure the strength of a correlation. Okay, let's see what is the strength of a correlation. Strength of a correlation. The more closely two variables follow the general trend, the stronger the correlation. In a perfect correlation, all data points lie on a straight line. That is kind of like an extreme case. We call that perfect correlation. In a perfect correlation, the scatter plot, all those points are collinear. They are on the same straight line. That doesn't happen often though. Yeah. So we need a measure. We need to be able to measure the strength of a correlation. Okay. Yeah. If we just look at the scatter plot, if those points are kind of very close to the linear pattern, the straight line, then we say the correlation is strong. Otherwise, if those points kind of scatter away from the straight line, then we say the correlation is weaker compared with this one. Let's look at an example. We have a few examples here. Example 1, we see a correlation. Let's figure out the two variables in the correlation. We see a scatter plot. Let's find the two variables in a scatter plot. X-axis weight of the diamond in carats. Vertical scale represents the values for price in dollars. So you can see the scatter plot has a linear pattern, right? And that also consistent with our common sense. For diamond, the rare stone, precious stone, the more the diamond weight, the higher the price is, right? By the way, in reality, it is not a linear correlation. But because, you know, if you have a 1 carat diamond, let's say the price is X dollars, 1 carat. And would that mean the diamond weighs 2 carats would the price as 2 times X dollars? That would be the price would be doubled? In reality, no, because the bigger stone, bigger diamond would be less common. I mean rare. You know what I'm saying? If the size of a diamond is doubled, the price, I think maybe triple or maybe 10 times, because that's even hard to get a diamond with that weight, right? But if we, based on the sample that we have here, we identify a positive correlation. Is that clear? Example 2, we have a scatter plot. Let's identify the two variables. Variable x on the x-axis, life expectancy in years. Y-axis, infant mortality, death per 1,000 live births. Yeah. So the sample has a few countries. I see India, Egypt, Kenya, Russia, Mexico, and we have some other countries here, Israel, Australia, and so on, Canada, Greece. So the sample contain countries. We're gonna look at, is there a correlation between the two variables, between the countries, between the life expectancy and the infant mortality in that country? Turns out we do see a linear pattern going down. Do you see the negative correlation here also? Doesn't that make sense? If people tend to live longer, that means the country provides the people with a good health system, right? Then that country might have lower infant mortality. In some other countries, like in Africa, maybe the health system is not very developed, and the people don't live very long, and the children or the infants has a higher rate to die. Yeah, it's also consistent with our common sense. You see this negative correlation. Example 3, we have two scatter plots. The one on the left, on the horizontal scale, we have the same day forecast in Fahrenheit. Vertical scale, actual temperature in Fahrenheit. Yeah, so this scatter plot tells us the relationship between the actual temperature of that day and the same day forecast. Obviously, you see a positive correlation, right? Yeah, those red dots. And the graph on the right, if you look at those blue dots, the horizontal scale represents 3-day forecast, and the vertical scale is the actual temperature. So the forecast is made 3 days before, ahead of time, 3 days before the day you concern. Okay, turns out you still see a positive correlation. However, if you compare those two scatter plots, do you agree that this one, the positive correlation of this one, is stronger than the positive correlation of this one? Isn't that like doesn't that make sense to you? If you do the forecast at the same day, of course it's more accurate, right? If you do the forecast 3 days ahead, then maybe the estimation a little bit off from the actual temperature. So the strength of the correlation, this one is bigger than this one. Does that make sense? As we have here, this paragraph, both scatter plots show a general trend in which higher predicted temperatures mean higher actual temperatures. That is, both show positive correlations. The points in the left diagram lie more nearly on a straight line, indicating a stronger correlation than in the right diagram. This makes sense because we expect weather to forecasts to be more accurate on the same day than 3 days in advance. All right. Next thing, possible explanations for a correlation. We have 3 possible explanations for a correlation. Your first step is to get a sample and construct the scatter plots for the sample. And then you take a view. You look at the scatter plot to determine if you see a positive correlation or negative correlation or no correlation. And then if we go deeper, we want to know if you see a correlation, what reason supports or what possible explanations for that correlation. So we have 3 here. Number 1, the correlation may be a coincidence. That's possible if your sample is not good enough. Number 2, both variables might be directly influenced by some common underlying cause. Number 3, one variable may be a cause of the other. All right, so look at those 3 possible explanations for a correlation, and then let's go back. Example 1, 2, and 3. What do you think about this? One variable causes the other, or both variables are caused by the same underlying cause? I would say one variable causes the other, because the bigger the diamond, the more expensive the diamond. So the size of the diamond causes the price. The bigger size of the diamond causes the bigger, higher price of the diamond. Example 2. How do you explain that? Coincident? One causes the other, or they both caused by the same underlying variable? You can pause and think. The answer is the 2 variables, life expectancy and infant mortality, both caused by the same underlying variable, and that variable is the health system, the quality of the system in that country. Okay, if the quality of the system is good in that country, you would see a bigger life expectancy and a lower infant mortality. Oh, I did it again. Mortal mortality. Well, if the quality of the country is bad, then you would see a lower life expectancy and a higher infant mortality rate. All right? What about that? One causes the other. Coincident? I wouldn't say coincident. One causes the other. I wouldn't say that either, because you cannot say forecast causes the actual temperature. That's kind of like weird, right? And you can not say actual temperature cause the forecast, because actual temperature is not happening yet. You do the forecast before the actual temperature. So I would say they are both caused by a common underlying variable, and that is the condition of the atmosphere, the condition of the weather. Okay, yeah, temperature is different from the weather. Temperature is just one of the measurements of the weather. Does that make sense? Am I clear about that? In this case, in this example 3, both variables are caused by the same underlying variable, and that variable is the condition of the weather. Next up, guidelines for establishing causality. Yeah, so sometimes when we look at a scatter plot and we see a correlation, we tend to explain it as one causes the other. but that not necessarily true. As I showed you, we have 3 different possible explanations. It totally could be just a coincidence if your sample is biased, or could be in this case, could be this case, both variables are influenced by the same common underlying cause. Not necessarily always be the number 3, one or the other, right? Then what, how do you know? How do you know if it's not case 1, case 2? How do we establish the causality between the two variables? If you want to establish the causality between those, we have a guideline here, 6 steps to investigate whether a suspected cause actually causes an effect. Follow these guidelines. Number 1, look for situations in which the effect is correlated with the suspected cause, even while other factors vary. Number 2, check that the effect is similarly among groups that differ only in the presence. Number 3, look for evidence that larger amounts of the suspected cause. Test the suspected cause with an experiment. We talked about experiment before, right? Determine the physical mechanism by which the suspected cause in the case study rate to high speed a disturbing also at it, thereby putting a child closer to the airbags than the child would be otherwise. To seal the case, safety experts undertook experiments using dummies, fake people. They found that children, because of their small size, often sit where they could be easily hurt by the explosive opening of an airbag. The experiments also showed that an airbag could impact a child car seat hard enough to cause death, therefore revealing the physical mechanisms, which is you can see it as a model by which the death occurred. Yeah, you can apply the 6-step guideline in this case. Confidence in causality. Possible cause, probable cause, cause beyond a reasonable doubt. How confident you are in the causality that you have established or you are considering. Possible cause, we have discovered a correlation but cannot yet determine whether the correlation implies causality. In the legal system, possible cause, such as thinking that a particular suspect possibly caused a particular crime, is often the reason for starting an investigation. Probable cause. We have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. In the legal system, probable cause is the general standard for getting a judge to grant a warrant for a search or wiretap. Cause beyond a reasonable doubt. We have found a physical model, keywords here, physical model, that is so successful in explaining how one thing causes another, that it seems unreasonable to doubt the causality. In the legal system, cause beyond a reasonable doubt is the usual standard for conviction. It generally demands that the prosecution show how and why, essentially the physical model, the suspect committed the crime. Note that this is very important. Beyond a reasonable doubt does not mean beyond all doubt. We know people are wrongly sued in the legal system, right? That happen a lot. My favorite movie, Shawshank Redemption, that could be one example. And that kind of things happen in reality as well. Let's see our package here. Number 1, when all the data points in a scatter diagram fall on a straight line, which of the following is present? A, no correlation, B, positive correlation, C, negative correlation, D, perfect correlation. All the points are collinear, fall on a straight line. That is a perfect correlation. Does that make sense? Yeah. As I said, that might not happen often in reality, but that is one case for correlation, perfect correlation. In a scatter plot is also called a scatter diagram. It's just a different name, the same thing. Number 2, which of the following exists when two variables tend to change in opposite directions, with one increasing while the other decreasing? For example, that one increasing, the other is decreasing. Remember, the price of the product, the demand of the product satisfy this linear pattern, negative correlation, right? That is a negative correlation. Number 3, which of the following pairs of variables is likely to have a positive correlation? Means the higher values of one variable correspond to higher values of the other variable. A, the airspeed of a plane and the time to its destination. The faster the plane goes, the less time it takes to arrive its destination, right? I think that's a negative. Okay? Yeah, the faster your speed, the less time that you need. That is negative. We do not choose that. We need to find the positive one. B, the number of auto accidents a person causes and his auto insurance premium. If you have a car, you should know that is a positive. You have more accidents on your record, and the insurance company would quote you more for your insurance because you are not a safe driver, right? And they might lose money because they insure you. So that is a positive. Does that make sense? C, the shoe size of an adult female and the education level. I would say no correlation. Okay? Women have good education, could have a small size fee, also could have a bigger size fee, right? D, the number of daylight hours and the amount of electricity used for home lighting. That is negative. If you have more daylight, then you would use the home lighting less. That is a negative. Hope that is clear. If not clear, you can email me, okay? Number 4, which of the following is true about a strong negative correlation? Yeah, if you take a statistics class, you would learn how do you exactly measure the strength of a correlation. But this is not a statistics class. We only touch the surface. We only need to know, maybe judge, determine a strong or weak just by common sense, or the pattern in the scatter plot. Yeah, we need to find strong. So the keywords here, strong and negative. A, points on the scatter diagram fall into a broad swath that slopes down. B, the points on the scatter diagram fall into a fairly tight line that slopes down. C, the points on the scatter diagram fall into a broad swath that slopes up. D, the points on the scatter diagram fall into a fairly tight line that slopes upward. Negative is supposed to be, if this pattern correlation is negative, does that mean the points are going down, the linear pattern going down? So C is out, D is out, right? And we want a strong, so those points are very close to the straight line, linear pattern, so fairly tight. Yeah. So we should choose B. B as in boss. 5. Which of the following relationships between pairs of variables is likely a coincidence? Remember the three possible explanations for correlation? The first one is coincidence. A. Higher energy levels among children who eat more sugar. Well, I would say it makes sense. Yeah, eating more sugar give the children more energy. I would say one causes the other. B. Higher test scores among students who die their higher rate. Coincidence. Connection between the two things. C. Higher income levels among people with education. I would say one causes the other. If you have more education, you would have a better income level. D. Fewer medical problems on people who exercise more often. Generally speaking, I would say yes. People who take care of themselves would have less medical problems. At least it helps, right? Number 6, which of the following is likely the result of some common underlying cause? Again, we have learned three possible explanations for correlation. This is the second case. Both variables are the result of a common underlying cause. A. Patients who eat a lot of salt often have high blood pressure. I would say yes, try to eat less salt. I would say eat too much salt would give you higher blood pressure. So one causes the other. B. Patients who have runny noses often have watery eyes as well. I would say that one is the case in which both of the variables are the results of some common underlying cause. Runny nose, watery eyes might be the result of allergies where you are sick, right? Yeah. Patients who exercise regularly often have better cholesterol levels. Yes, I would say one causes other. At least it helps. Second idea laundry. I don't see one causes the other. B. It was hot and humid, and then it stormed. I would choose because my surface not just correct earlier very randomly. Wait, come on. Restore my surface. Okay, finally, where were we? We were talking about number 8, right? Which of the following is a guideline for establishing causality? A. Consider only the suspected cause, ignoring. Yeah, I'm trying to highlight those keywords. Ignore only. B. Seek evidence that larger amounts of the cause produce larger amount of the effect. C. Ignore. See the keyword? Ignore evidence that suggests there is no causality. D. Avoid. Keyword avoid. Having to do an experiment as they are usually costly because it's expensive. So only, ignore, avoid, those are just kind of lazy words. Yeah, you the C, just make sense of it. We choose B, B as in boy, number 3. That's the number 3 in the guideline. Step 3 in the guideline. Number 9, investing a homeowner's complaint. Investing a homeowner complaints against the home builder. An inspector finds that all the reported problems can be explained by poor drainage. Yeah, that's a very important thing, drainage. This explanation is an example of which of the following? Which one? A common underlying cause. B, a physical model demonstrating causality. C, positive correlation. D, confidence. I would say A. Okay, all those things going on are the results of one reason: poor drainage, a common underlying cause. Number 10, which of the following best describes our level of confidence in causality when we have found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality? Of course, you choose the strongest one, cause beyond a reasonable doubt, right? Okay, so that's everything about this section. Please do your day quiz on time. Email me if you have any questions. Thank you for watching.